When we think about Ohm's law, the mathematical equation V equals I times R usually comes to mind. But this doesn't show the complete picture. As an electrician, you'll use Ohm's law daily, so you must understand its principles. Just knowing the formula will not be enough. So let's get into this. For anyone working in the electrical trade, the fundamental principles of Ohm's law can easily be observed in any circuit. We can think of an electrical circuit like a racing circuit. It begins at a specific point and follows a path until it eventually loops back to the same starting point. A practical electrical circuit will include a power supply, conductors to carry current, a load to do some work, and a control device to operate the circuit. To indicate the rate of current flow, we can include a measurement device. Comparisons can help explain complex concepts. The water circuit comparison is a useful tool for understanding the operation characteristics of electric circuits. The power supply here is a water pump supplying pressure. Circuit conductors are represented by clear plastic tubes, and the load is substituted by a restriction tube. A hand-operated valve provides flow control. In an electric circuit, voltage is the electrical pressure applied to push charge units through the circuit. This is like pressure in a water circuit. Electric current corresponds to the flow of water. Resistance in an electric circuit is like a restriction in a water pipe. A resistor in an electric circuit generally has much more resistance than the circuit conductors. When we operate the valve, water flows. It acts like a switch in an electrical circuit. Let's measure the water flow in the circuit. Now, let's have a look at the current flow in our electrical circuit. When we increase the pressure supplied by the pump, we can observe a change in the flow rate. A higher pressure produces a higher flow, and a lower pressure produces a lower water flow. By changing the voltage in our electrical circuit, we can also observe a change in the current flow. What do you think will happen to the water flow if we increase the restriction or resistance in the circuit? Let's test this by replacing the restriction tube with a narrower one. By adding more restrictions in the water circuit, we decrease the flow rate. By comparison, this is what occurs in the electric circuit when we replace the resistor with a higher value. On the other hand, a larger tube brings about a higher flow rate in the circuit. We can see the same response in the electric circuit. As we have seen, an increase in voltage will bring about an increase in current flow. A decrease in voltage will cause the circuit current to reduce. An increase in the circuit resistance will reduce the current flow. A decrease in the circuit resistance brings about a higher current flow. Watch our next video to understand how this can be applied to your everyday electrical work.